Before I convince you that aerobic granular sludge reactors are the future for wastewater treatment plants, I need to ask you a question. Do you know how much space we need to treat the wastewater of the whole Flemish population? Well, we need 120 football fields. But if we could replace all the activated sludge plants by aerobic granular sludge plants, we would only need 1/4 of that surface. But sad enough, almost all municipal wastewater is treated in continuous flow reactors with activated sludge. Activated sludge has a low biomass concentration and also a low settling velocity. So the treatment capacity of these installations is low. However, the effluent criteria are becoming stricter and more wastewater needs to be treated. So the space and also the energy and costs will increase even more.
If we choose the aerobic granular sludge technology, we can get rid of the big settlers from conventional systems. Besides, we can make all the biological reactions take place in a single tank. And this is because we make biomass growth forming aggregates that we call granules. They are cultivated in batch or discontinuous reactors. They are dense, they settle fast, and they can increase the treatment capacity of our system. This means that we can reduce not only the space that we need, but also the energy and the operational costs. We know that this technology works. Indeed, it has been successfully implemented at full scale, but can we make it even more sustainable? Can we optimize even more this process? The answer to this question is yes. And this led us to ask two more questions. Firstly, could aerobic granular sludge be integrated in already existing wastewater treatment plants? If you are interested in knowing the answer of this question, you should choose our thesis topic number 1. We know that granules can be cultivated in batch systems, but what about continuous flow reactors? With this master thesis, you will study different alternatives of aerobic granular sludge reactors through modeling and simulation, with the aim of finding the most sustainable technology, the most sustainable alternative to treat the wastewater.
And then we have thesis topic 2. The question here is, would it be possible to know when the wastewater is clean enough through Offgas analysis? The Offgas is the gas that is leaving the reactor, and this is never measured before. Normally, we measure the liquid phase. So we measure all different variables to control the process. However, these analyzers are very expensive and also labor intensive because we need to calibrate them a lot. And this is not the case for Offgas analyzers. They are full of interesting information. We can measure oxygen and CO2 and use this data to control the process in a way that is never done before. So therefore, you will set up a lab scale reactor to measure the Offgas, and then you will also model and simulate to validate your results and to propose Offgas-based control strategies. This all to meet our sustainable objective. So if you are interested in one of these topics, you can send us an email for more information. We are part of the Biosystem Control Group of Professor Evelien Volke, and we are very happy to welcome you in our group.